Okay, so this would be considered an and compound inequality because this side has to be true and this side has to be true. So I'm going to actually treat it as two separate things to start out so that I can get my two solutions. So I'm going to start by kind of like what I just did. I'm going to take each of these individually and solve them. Okay, so I'd be subtracting 3. That's going to give me 0. Now, when I divide, I have to be careful because I am dividing by a negative, which means that our sign has to flip. So when I write this out, that less than has become a greater than. A lot of you don't like seeing it this way. If you prefer to switch it around and have your x on the other side, you do have to flip everything, so this would become x less than 0. Okay, so now for the other half, this guy, I'm going to solve him too. Same idea, subtract the 3. And I'm going to, again, need to make sure I flip my sign when I divide by a negative 4. So this will now read x greater than, and you can leave it as negative 9/4, or if you prefer, you can also write the decimal equivalent since it's a terminating decimal, so I'll just kind of put that in parentheses. Okay, so off to the side, I had made a note that I want us to put our solution graphically and using set builder notation. So I'm going to go ahead and draw my number line. Mark off my two solutions. Since negative 1.75 is smaller, that one has to go first. Since I had regular less thans and not less thans or equal to, I'm going to put open circles here. And so now I have to kind of interpret what I have. So this says that x is less than 0, which would mean we're shading to the left of 0. And then this one is x greater than negative 9/4, which would mean I'm shading to the right. So these are going to meet right in the middle. You cannot overlap one of your solutions, because they have to, remember, this is an and, they have to be true at the same time. So that's our solution graphically. Now I'm going to go ahead and write my set builder. Because this is an and I've shaded the middle region, I can write this as one big inequality. If that's a little confusing for you and you prefer to keep them separate and use a word in between, we could also have that x such that, and just write your two distinct answers from before. So you could say x less than 0, but you have to make sure you use the word and because we shaded the middle. X greater than negative 9/4. I'm going to run out of room. Okay, so that's my solution. Okay, so I also want to show you an or, just so you can see what that looks like. So this means they're actually two distinct inequalities that we have to solve. So I'm going to go ahead and just solve right from here. This gives me 5x is less than or equal to negative 10. Note here, I do not have to flip my sign because the number I'm dividing by is positive. It doesn't matter that the 10 is negative, so this sign stays exactly the same. So I get x less than or equal to negative 2. Over here I solve. And I get that x is greater than 4. I didn't write here what to do. I forgot to do that part, so let's just go ahead and again do a graph and do set builder notation. So for my graph, negative 2 has to go on the left, 4 goes on the right. If I look at my symbols, the solution with negative 2, that needs a closed circle because it was less than or equal to. And for the 4, I'm going to leave it open because it was just a greater than. Okay, so again, I need to interpret what this says. This is saying x is less than or equal to, which implies we're shading to the left. And this one is x greater than 4, which implies that we're shading to the right. So we do this time around get two distinctly different shaded regions. So now when I write this using set builder, I can't even try to write it as one because the two shaded regions are not connected. So I can just take my two solutions from before, and I want to make sure I'm putting the word or in between because these cannot happen at the same time. And that's my final answer.